So now a word problem to try to illustrate instantaneous rate of change. Word problems, I think they're more illustrative. They might help you understand the concept better. So I came up with a typical beginning calculus problem. So a pebble is dropped from a 288-foot cliff, takes the pebble 3 seconds to hit the ground, and this formula, f of t equals 288, which is the height of the cliff, minus 32 times t squared, can be used to find the pebble's height in feet off the ground for the 3 seconds that it's flying. So for this function right here, the numbers in the right-hand side represent time in seconds. And what I get out, if I plug in a time in seconds, is the pebble's height off the ground in feet. So if I was to find 2 points and find the slope of the line between the 2 points, the x's are going to go in the denominator. The y's are going to go in the numerator. The y's are feet. The x's are seconds. And the average rate of change between 2 points would be the average speed in feet per second. When I do the instantaneous rate of change, it's going to be its instantaneous speed, and instantaneous speed is actually called velocity. So let me try to work with this function. First, I'm going to find the average rate of change, its average speed for the 3 seconds that it took to hit the ground. So to find the average rate of change, I need to know 2 points. I need to know for the whole time that it's flying, from the moment that it started being dropped at time 0 to time 3, what its height was, because the average rate of change is going to give me its average speed over the time interval. So let me get the x's have to be time, and let me get the first y. For the first y, I can plug in 0 and do f of 0, which is 288 minus 32 times 0 squared. The 32 times 0 squared is going to be 0. So this is going to be 288 minus 0. And at 0 seconds, the pebble's at 288 feet high. At 3 seconds, it hits the ground. So when I do this, when I do f of 3 and do 288 minus 32 times 3 squared, this, if I do it on my calculator, is going to give me 0. So it says at 0 seconds, right at the instant it starts to fall, it's at 288 feet. At 3 seconds, it hits the ground, and it's at 0 feet. What's the average rate of change? Well, the average rate of change is the slope of the line that connects the 2 points. So my average rate of change is going to be the y-coordinate of the second point, 0, minus the y-coordinate of the first point, 288, divided by the x-coordinate of the second point, 3, minus the x-coordinate of the first point. That gives me negative 288 over 3. The numerator is the distance in feet. The denominator is the time in seconds. This gives me negative 288 over 3. And I'm going to write feet per second. And I did this on my calculator. And notice I get a negative sign here. Its average speed is negative 96 feet per second. The negative indicates that it's falling as opposed to rising. If I was doing a problem like I was shooting a rocket into the air, when the rocket is going up, its average speed and its instantaneous speed is going to be positive. When it's coming back down, its average speed and its instantaneous speed is going to be negative. So this, for the 3 seconds that it was falling, its average speed was 96 feet per second. Negative indicates that it's falling. Now let's find the speed when it hits the ground. So right when it hits the ground, what's its speed in feet per second? Well, how do I find instantaneous rate of change? I need 2 points. This is the x value of one of the points. And the function is f of t equals 288 minus 3t squared. So the x value of my first point is 3. To get the y value, I take the x value and I plug it in for, or in this case, the t value, because this is time and not really x, but it's in the x position. When I plug 3 in for this t, I do the algebra and I get 0. So that's my first point. My second point, I have to do the trickery. Its x coordinate is 3 plus h, and its y coordinate, I have to do the horrible algebra to figure out. What's the horrible algebra? It's going to the function, changing the t to 3 plus h, and that's going to be the y coordinate of the second point. Let me do this math. Go 288 minus 3 times 3 plus h times 3 plus h. To get the y coordinate of my second point, I need to do this math. I'm going to work on this first. Do the first, which are 3 times 3, which is 9. The outers are 3 times h, which is plus 3h. The inners are h times 3, which is plus 3h. The lasts are h times h, which is plus h squared. Let me write this a little bit nicer. I have the 288 that I haven't dealt with yet, the minus and the 3 that I haven't dealt with yet, but I've cleared the parentheses. The parentheses comes out to h squared plus 6h plus 9. Now I'm going to multiply through by negative 3 to clear this parentheses and get 288 minus 3h squared minus 18h minus 27. I'm going to combine the 288 and minus 27, and there should be a 32. I think I'm messing. That should be a 32 out front. This should be minus 32 t squared. So this 3 right here should be a 32. This 3 right here should be a 32. This 3 right here should be a 32. That makes things a whole lot worse, but let me fix that. So I get, let me rewrite this line. I have 288 minus 32 times h squared plus 6h plus 9. And now I'm going to go 32 times h squared. So I'm going to get 288. And then minus 32 times h squared is minus 32h squared. And then minus 32 times positive 6h. So I go minus 32 times 6 and get negative 192h. And then minus 32 times 9, I get minus 288. So for the y coordinate of my second point, the 288's cancel. The y coordinate of my second point is negative 32h squared minus 192h. There I wrote it backwards, but it doesn't matter. So the 2 points I'm going to use, the point 3 comma 0 and the point 3 plus h, negative 32h squared minus 192h. So how do I find the derivative or slope of the tangent line? Well, I just do y2 minus y1 over x2 minus x1 and take the limit as h goes to 0. Let me get some different paper so I can write better. So I have my 2 points. I'm trying to find the instantaneous rate of change, and the numerator is going to be the y's. The denominator is going to be the x's. Because I'm using the f function, I'm going to write f prime, which is the instantaneous rate of change when x equal to 3, or the value of the derivative when x equal to 3 is the limit as h approaches 0 of the y2 minus y1. y2 is negative 32h squared minus 192h minus y1, which is 0. In the denominator, it's enough just to put h, but I can do x2, which is 3 plus h, minus x1, which is 3, subtracting the x's. So the instantaneous rate of change in this numerator is going to be the difference in the height in feet. The denominator is the difference in time in seconds. The instantaneous rate of change in feet per second, that's going to be its exact speed when at 3 seconds, is negative 32h squared minus 192h. That's what the numerator simplifies to. The 3's cancel on the denominator and I just get h. Now I'm going to factor out an h from the numerator, get the limit as h goes to 0 of h times negative 32h minus 192 over h. I'm going to cancel, and get the instantaneous rate of change, which is the speed, more properly the velocity at 3 seconds. I'm going to get by taking this and plugging in 0. So the derivative, or the instantaneous rate of change, is going to be negative 32 times 0 minus 192, which is 0 minus 192. And let me tack some units on that I'm neglecting. The instantaneous rate of change, the number is negative 192. The units are going to be feet in the numerator per the denominator. So it's going to be feet per second. So what I've done here is I found the velocity, or the speed, when the object hit the ground right at 3 seconds. That's heady. If you understand it, you're well better in terms of understanding math when I was in your position. Now we just need to push through some algebra in the section and see where it takes us. And everything that we did now, I've done everything technically that needs to be done. This is just now, I did all the theory, now we're going to do the homework problem. So I spent a half hour or 40 minutes doing the theory. Now let's do some homework. So first few problems come from the beginning of the section. They're just average rate of change. Find the average rate of change for the function over the interval. Sketch a graph to model your answer. So the average rate of change is simply the slope of a line that connects 2 points. And the first point has an x-coordinate of 3 in number 2. The second point has an x-coordinate of 4. Let me get the y's by going f of 3 equals 3 squared minus 5 times 3 plus 2. That will give me the y for the first point. And then do f of 4 equals 4 squared minus 5 times 4 plus 2 to get the y-coordinate of the second point. So first point, y-coordinate is 3 squared minus 5 times 3 plus 2. First point has a y-coordinate of negative 4. Second point, its y is 4 squared minus 5 times 4 plus 2. Second point has a y-coordinate of negative 2. So now I'm going to find the average rate of change. The average rate of change is just the slope of the line that connects those 2 points. Doesn't have any units to this because this isn't a word problem. So the average rate of change, I'm going to do the y-coordinate of the second point, negative 2, minus the y-coordinate of the first point, negative 4, over the x-coordinate of the second point, 4, minus the x-coordinate of the first point, 3. The double negative in the numerator turns positive, so I get negative 2 plus 4. The denominator comes out to be 1. This gives me 2 over 1, and the average rate of change is 2. I don't think on the tests I make you graph, so if you skip the graphing part of this, so be it. I want to show you the graphs just because it's easy for me with technology. So I graphed the function, And then this is called a secant line. It's a line that measures the average rate of change between 2 points. This line has a slope of the average rate of change of 2. So if you skip the graphing, so be it. It's just not going to matter. It's probably more hassle than it's worth. Let's do another one of these average rate of changes. I'll do number 4. I'm going to do the average rate of change of that function between 2 and 7. So I need to create 2 points. The first point's going to have an x-coordinate of 2. The second point's going to have an x-coordinate of 7. The y-coordinate of the first point is going to be found by plugging 2 in for x into the function for number 4. That's going to be the square root of 4, which is 2. So the first point I'm going to work with is the point 2, 2. You'll notice that I try to make the numbers come out nice. My goal is not to, humiliate you with ugly numbers. I just want you to be able to do the problems, without the math grunge, with the math grunge being as kind as it can be. So now I've created my x's and my y's. My average rate of change now is just the slope of the line that connects the 2 points. Sometimes I use a little triangle instead of writing change. And I'm going to go y2 minus y1, 3 minus 2, divided by x2 minus x1, 7 minus 2. And the average rate of change is just going to be 1/5. I went ahead and drew this. I graphed the function the square root of x plus 2, and I plotted the point negative 2, 2 and the positive 7, 3, connected the line. The slope of this line is going to be 1/5. So I'll say the slope of this secant line is m equals to 1/5. And again, if you don't graph this, it's not going to make any difference at all. It's just kind of nice to see it. It'll make a connection nicer. Let's do one more of this kind and then move on to another kind of problem because this looks ugly. So number 6, find the average rate of change using different notation. Exponential functions and t's and s's, but this matters not. My first point has an x-coordinate of 0. My second point has an x-coordinate of 1. To get the y-coordinate of my first point, I'm going to plug 0 into the function and get 3 to the 0 power. 3 to the 0 power is 1. To get the y-coordinate of the second point, I'm going to plug 1 in for t and get 3 to the first power. And 3 to the first power is 3. So now my average rate of change is just the slope of the line that connects the points. So it's 3 minus 1 over 1 minus 0. That's 2 over 1, which is 2. That's the answer that I need. And again, I graphed the function 3 to the t. I plotted the points 0, 1, 1, 3 and connected them with a line. This again is called a secant line. This line right here has a slope. I think it came out to 3. I already forgot. This line right here has a slope of 2, for what that's worth. I'm going to, I better do, let's do 7 with you. I hate to skip this one. Let's do 7 together. So for 7, I told you I would solve 7 in the video. Instead, I read myself so well, I didn't even read that. So for 7, the first point has an x-coordinate of 1. The second point has an x-coordinate of e. The y-coordinate of the first point is the natural log of 1. The y-coordinate of the second point I get by plugging e in for this. It's the natural log of e. These I can both do on my calculator. So to do the natural log of 1, that's easy. I just type the natural log button, type in 1, and the natural log of 1 is 0. The natural log of e is a little clunkier. To do the natural log of e, I type the natural log button, and you'll see on the divide key the e is written there. If I hit the second button in blue and the divide key, that gives me the e, and the natural log of e is 1. So now I have my x's and my y's. I can find my average rate of change. My average rate of change is It's y2 minus y1. So that's 1 minus 0 over x2 minus x1, which is e minus 1. That's 1 over e minus 1. That's a great answer. The equivalent decimal answer is 0.58. To get that decimal, I go 1 divided by parentheses, second and divide for e, minus 1. And there's my 0.58 or 0.58. I sketched a graph. I think this is actually yours. And E is 2.718. I couldn't get my program to write E. Again, not that big of a deal. Let's do another average rate of change. I'll do number 9. A 9 talks about a scuba diver. In fact, let's do 9. Let's do 9. Flying dangerous because I don't have this answer. A climber is at a hike. After 2 hours, his altitude is 400 feet. After 6 hours, his altitude is 700 feet. Probably didn't go straight. She or he probably didn't go straight up. It kind of probably meanders. What's the average rate of change in the climber's height? I'm going to find its average rate of change in feet because that's the distances per hour. And I can do this real quickly. The hiker went 300 feet in elevation in 4 hours. Whatever 300 divided by 4 is, about 75 feet per hour. But to do the average rate of change, I need 2 points. I'm going to make the x as my time. So after 2 hours, he was at a height of 400 feet. At 6 hours, he was at a height of 700 feet. This is sexist. I should have done something more non-sexist, but it is what it is. So the average rate of change is just the distance, 700 feet elevation minus 400 feet elevation over the times. At 6 hours minus 2 hours, the average rate of change is going to be positive, 300 over 4. The units are feet in the numerator, hours in the denominator. I think that's 75 feet per hour because the numerator is the distance in feet, the denominator is the time in hours, and I get average rate of change. When the word problems, I have to tack units on, and their feet per hours feels really good. Was not feeling creative when I wrote this. I don't like my problem 12, so let's do number 11. Again, flying dangerously because I don't have any answers written with me, which is dangerous. I don't want to make many mistakes in the videos. So a rocket is 1 mile above the Earth in 30 seconds and 5 miles above the Earth in 2.5 minutes. What's the average rate of change in miles per second? So what I need to do is create points, and to get miles per second, the time of seconds need to come first. The distance in miles need to come second. Because to get miles per second, the miles need to be in the numerator, the seconds need to be in the denominator. Well, the first bit of information, at 30 seconds we're at 1 mile. Well, that's not miles, it is miles per second, so that's good. So at 30 seconds, height is 1 mile. I feel good about that. But the second point, the height is 5 miles. 2.5 minutes is not in seconds. I need to multiply 2.5 by 60 to get it into seconds. So 120 seconds for 2 minutes, and then the extra half a minute gives you 30 seconds. It's going to be 150 seconds. So now I can do my average rate of change. The units in the numerator are going to be miles. The units in the denominator are going to be seconds. So my answer is going to be in miles per second. So let me form my fraction. Y coordinate of the second point minus y coordinate of the first point divided by x coordinate of the second point minus x coordinate of the first point. This is going to give me 4 over 120 miles per second. And I'm going to reduce that fraction to 1 over 30. So for number 11, the rocket is moving at 1/30th of a mile per second. Apparently, I didn't like 13, I deleted it, and 14 I wrote in red because it wasn't part of the homework. One more average rate of change, and then we probably can move on to a part 3. I don't even really know that we need to do one more. So let me skip this. You can try 14. I'm going to pause the video and do a part 3 that has instantaneous rate of change problems. And I know my dad just called, and I will call him so he doesn't fret that I didn't answer his phone call.